So in this video we're going to go over proof by contradiction. So in proof by contradiction we have an implication we want to prove. P implies Q. We want to prove that this is true. And instead of trying to directly prove that P implies Q is true, we say suppose P is true implies not Q is true. And what we want to demonstrate that is if not Q is true, it leads to a contradiction. It leads to P being a false statement. So we assume P true. We assume that not Q is true. We assume that P implies not Q is a true statement. We show that if not Q is true, then not P is true, which means P is false, which contradicts our assumption that P was true. So essentially in steps, the proof by contradiction, assume P implies not Q is true. Assume not Q is true. And if not Q is true, the only way for P implies not Q to be true is for P to be true. So in step 3 we show not Q implies not P, which means P is false, and that's your contradiction. So let's go ahead and do one. So here we have the proposition, if 3n plus 2 is odd, then n is odd. So to do a proof by contradiction, what we'll do is assume that 3n plus 2 is odd is a true statement, and we're going to assume that 3n plus 2 odd implies n is even, and show that that forces a contradiction to happen. So again, we start by telling the reader that we're ready to do our proof, and we tell them what type of proof we're going to do. Contradiction. And we tell them this so they know what to expect. The reader knows to expect. If I say I'm doing proof by contradiction, they know to expect me to assume 3n plus 2 is odd and n is even, and show that that leads to a contradiction. So suppose 3n plus 2 is odd, and instead of being odd, n is even is what we'll assume. Well, if n is even, what does n look like? Well, it follows that if n is even, n is an integer multiple of 2. So we say that n is an integer multiple of 2. Therefore, now we'll do a little bit of math. 3n plus 2 equals, we assume that n is even, which means we can replace the n with 2k from right here, plus 2. This equals 2 times 3k plus 2. And now we can see that 3n plus 2 is an integer multiple of 2, which means 3n plus 2 is going to be even. So equals 2 times k sub 2, where k sub 2 is the 3k plus 2 integer. And now we see that 3n plus 2 is an integer multiple of 2, indicating that 3n plus 2 is even. So this right here, this 2k sub 2, this implies that 3n plus 2 is even, a contradiction. Why is it a contradiction? It's a contradiction because we assumed that 3n plus 2 was odd up here. Therefore, if 3n plus 2 is odd, n must be odd. And again, again, n must be odd because if n is even, it leads to a contradiction, and this ends our proof.